while we're getting that going. Um, First of all, so excited to be here. This has been just absolutely incredible. I appreciate these things, if not for the sole reason that they remind me that there are always a lot smarter people in the room than myself, and I appreciate that. This presentation is called Why Go. I was given basically the option of choosing my own topic here, and so let me explain a little bit about kind of why I chose this. Oh, first of all, I'm Nick Lloyd. I'm the VP of Engineering at. I chose this topic because in large part previously, because the last time I gave a presentation at the Go meetup, I went really, really deep and nitty gritty on Go's garbage collection system, and I lost the entire audience. Like, just super fast. I went way too far. It was really pedantic. I shouldn't have done that. And so I'm trying something new, which is I'm going way high level instead of trying to dive down deep through some big technical issue. So hopefully this works out. We're going to find out if I do a little bit better at maintaining the crowd. So a couple of caveats. I'm talking about why Go, why people are still using Go, why companies are choosing to use Go. But just right off the bat, I'm a believer in using the right tool for the right job. So I'm not advocating that every single possible thing should be built in Go. I don't believe that there's always one right tool. So there are frequently more important factors than code performance architecture when you are choosing to build particularly an MVP, right? When you're building projects from the ground up, choose to do something that you know really well. So another caveat. And then this last one is a caveat on the fact that I am not a designer. My aesthetics are terrible. I do a lot of bullets and blocks of text. I apologize. So how I came to Go. I'm going to start off with like why I use Go, why Route uses Go, and then I will transition a little bit into why other people are using Go. So I learned to program in C and C++ when I was younger. And then, I did a lot of things before coming back to start my career in tech. But when I came back, I went to school for a computer science degree. And, I went to the U. If you went to the U, a few years ago, most everybody learned in Java. And then you got thrown into C and C++ for some of the lower level classes. And then I started off my first professional gig in C and C++ and a little bit of x64 because we were doing custom hardware stuff up at Raytheon, which is where I started my career. And I love low level languages, probably just because I learned that way. Anyway, so I moved to working in Python after that, though. I could kind of change directions. I went to a fintech company that was using Python in a very interesting way. They were using Python because they wanted something where they could attract coders, younger coders. They'd previously been operating in C, and they wanted something that was a little bit more readable and could attract a different group of engineers. The problem with it was that Python just was not fast enough for their use case, and so they were freezing it, which was a really fun thing to do to Python. Anyway, so I learned Python there. I was working in kind of both Python and C because they were switching out of C. And then I went to another startup pretty quickly where I started there because they were in Python. They were also using Django. I hadn't used a platform on Python previously. And I grew to hate that pretty quickly. I like to have a lot of choices. I like to be able to do things my way and not have things dictated for me. So I decided to do a project for this company that was primarily, again, the back end was when I got there already in Python. I wanted to do a project on a separate system. So this was a real-time notification system that I needed WebSockets to do. I did not want to lash that into the Django monolith that we had because I didn't like Django's implementation of WebSockets, and for scaling reasons that I didn't think that was going to work out very well. So I knew right off the bat I was going to be making a new service for this. And I wanted something that was relatively lightweight. I wanted something that I felt like I could scale really easily. And I knew that we were operating in AWS at the time. I just wanted to be able to scale it horizontally. And I cared about the ease of concurrency because it was a very IO bound workload. And so that mattered to me. Again, I really hated working in Django. I didn't like the limitations that were imposed on me. I didn't like having how I interacted with the database dictated to me. That was a real pain in my butt. And so, I decided that Go was the way to go when it came to building this project. It addressed these issues for me, and I was already familiar with working in C. I thought so the syntax here, low level syntax is good for me. So then what? The project was a success. The Vandy story here is that I left that company pretty quickly after the project was finished. They called me about 5 or 6 months later, and they were like, "Hey, where's that code for that project?" And even the infrastructure, the Terraform for it, and all of that. And because it had just been happily working with no problems in the background for 5, 6 months, nobody had to touch it. Pretty pleased about that. But like I said, I left there pretty quickly. I had learned to love growth through building that project. And so I decided, hey, I want to go somewhere where I can continue working in Go. And so I went to a couple of different places and finally ended up at Route. The new CTO who had just come into Route had made the decision that he wanted to build the backend systems in Go, or at least the initial ones. I was his first engineering hire there, and I was really excited about it. I was like, great, this is an opportunity for me to go build a lot of brand new Go code with some people who have done this before. And I had the chance there to build a lot of the base architecture and a lot of the core systems that are still in use today, albeit, as any of the Route engineers here will tell you, heavily modified at this point. Thank goodness for that. So why does Route love Go now? And I'm going to give you my answer first. First of all, as I mentioned in reasons that I decided to use it in the first place, I like that it's really lightweight. I love that you can build containers that are less than 15 megabytes. This matters in a cloud environment because you can stand up, clusters of microservices, and every little bit of memory counts. We're not operating in a system where that memory just becomes more it doesn't matter over time because we have changed the size of the tasks that we're doing. And so over time, you can get real cost savings with lightweight services and containers. I like it a lot because it's a really easy to understand concurrency model, which, coming from a C and a C++ background, I understand how to do concurrency in C and C++. It's a hard thing to explain to other people how to get going in. It's a very difficult paradigm in which to understand how to track down errors and things. I think Go solves a lot of those problems in a very elegant way. And a lot of the workload at Route is absolutely based on multi-threading and being able to do concurrent workloads because we're very queue-fed for a lot of our microservices. One of the things that I also appreciate, and one of the talks was on this, right? Unit testing. As long as you're careful about dependency injection, that's a little bit of an inside joke. I think that the unit testing capability of Go is just absolutely phenomenal. As was previously mentioned, it's right out of the box. There's no, question of hey, what am I going to go use? You've got it right there, and it works really well. In my opinion, Go forces easier readability than a lot of other languages do. I was a heavy user of the ternary operator in other languages. I thought it was really cool because I could write these things that were so concise. And over time, what I realized, as many of you have, is that you can write some really cool things that are very concise and very elegant that nobody's going to understand on first pass the next time it's looked over. That's a real problem in a production environment. It's not a problem if you're writing that code and you're the only one that's ever going to work on it. Great, go ahead. But otherwise, somebody's going to need to be able to understand that code. And I really appreciate the fact that the simplicity of the syntax and the way that they force you into writing maybe a little bit longer but more understandable code I think it's absolutely fantastic. And then, again, going back to like the things that matter when it comes to cost savings in a cloud environment, I think the performance of Go really makes a big difference, particularly for microservices. So these are the reasons why I think that Go is continuing to be a really good choice for route. Of course, like there are engineers who are down deep, way more in the code than I am at this point. And so I started crowdsourcing some answers here. What do other engineers at Route appreciate about using Go? Some of the answers that I got: strips out unneeded bloat from inheritance using composition. Interface struct relationships, extremely powerful. Strong backwards compatibility. This one I hadn't thought about until one of the engineers pointed that out. And I thought, oh man, I couldn't agree more. I have been in, I've worked in Python, going from Python 2 to Python 3. Holy crap. Huge disaster. It's a major, major benefit to have strong backwards compatibility. Great package management and versioning with modules. Going back to that question, when did it come out? Version 11. It's been really strong since then. It took me a little while to get used to that when it was released. I was used to doing some really funky things to try and get even internal tooling built into my projects. But it's really cool once you get in there and get using it. No runtime dependencies, easy cross compilation, core libraries are built for application building, i.e. HTTP clients right out of the box. I think these are all really great answers. A lot of this stuff, I mean, when you open up I'm going to pick on Java. When you open up a Java project, if you want to build an HTTP client, you're going to bring in 4, 5, 6 different libraries just immediately because you've got strings. That's great. So who else loves Go? I'm sure most of these, hopefully everybody here is raising their hand. There's a lot of companies that love Go. Obviously, it was created at Google. They use it for a lot of projects, a lot of internal projects, and a lot of very customer-facing projects. Docker is another one that's pointed out regularly as a major success story for Go. This is a system that operates just at an incredible level of compute and detail and operates in Go. Dropbox, Uber, 1Password, Kubernetes. I mean, the list goes on. I thought about including all of the Utah companies. There's just so many, right? It's amazing actually how much of a hotbed for Go this area is becoming. I think it's really, really cool. So I'm going to kind of switch gears into what other people like about Go. So I've spent a lot of time talking about Go with other engineers. I have friends at a lot of really big companies, some friends who have used Go and then moved into other languages, some who've stayed in Go. And then I also, when I started prepping for this presentation, I started talking to some more people as well. Kind of started off thinking about trying to talk to engineering leaders. Realized pretty quickly that was a mistake for a couple of reasons. A, they're all really busy. And B, like they're not the ones you should be talking to, right? It's engineers who should be making decisions about the stack, who are in it every day and working on it constantly. And so I just got to working and talking to engineers about this. So, the general themes follow with with what all of you frankly know and what you're gonna find on the internet. People love the performance of Go. People love how easy it is to learn. It's not object-oriented, and I know there's some nuance there. It's open source, and there's ease of maintenance. This is kind of the categories that I pushed a lot of different commentary into, and I'm going to talk about each one individually. So performance-wise, a lot of people start comparing Go to much lower level languages. This is a huge deal that we don't talk about very frequently. I mean, the fact that you have a language that builds in a lot of developer accelerators like garbage collection to systems that don't push that stuff in, and you still talk about its performance like you talk about those, that's a big deal. As we got further and further from those lower level languages with things like Python and Java and a few others, or a lot of others, we started getting slower because we were adding so many things to the languages that just you got right out of the box that were going to immediately affect your performance. So it's a big deal that when most Go developers talk about the performance, they're comparing it to a totally different subset of languages than the one that really it falls into, which is, hey, we've got a lot of developer accelerators. Most of the people that I talk to believe that Go heavily performs that other subset, right? Java, Python, JavaScript. And some of them will go to, hey, like I've run specific benchmarks for the kind of workload that I'm operating under, and so I know in very specific cases that Go is more performant than these languages. And of course, there's also outliers on the other side of that. You can absolutely find certain kinds of workloads that are going to work better, but in general, the consensus is like, hey, performance-wise, Go outperforms these languages. Concurrency, again, and I talked about concurrency. This heavily factors also into the performance perception. If you make it very difficult to operate concurrently in your language, you're going to try and find ways not to do it. And so your performance is going to suffer. A lot of people cited benchmarks around regex. This is a classic one in software engineering. Regex is used as a baseline for a lot of different languages and other systems. Go's is actually, and I always love that comparison because I am a big regex nerd, and I really love to see when you have a powerful implementation of regex. And then, universally, developers believe that just in general, Go is a great performer. I think this stems from the fact that, we tend to associate a lot of abstraction with lower performance in general. And you don't get a lot of that really, really high level abstraction in Go, especially not right out of the box. And so I think a lot of the things that we think about when it comes to performance are very much affected by the fact that it's lightweight. So another category here that's a really common refrain when talking to developers in Go is that it's easy to learn, particularly when you're coming from pretty much any other language. As long as you have some kind of background in how to program, getting to Go is not very difficult. The syntax is relatively simple. You are pushed away from doing things that don't look like what they are. And so it's really relatively easy to learn. And in fact, one of the interesting things about my personal experience with talking to developers in Go is that if people have been in the industry for a while, I very rarely find somebody who has only worked in Go unless they're straight out of school and it is the first language that they worked in. That's fairly rare. Most people are coming into Go from other languages. Now, part of that has to do with the fact that Go is relatively new on the scene. But it's also a testament to the fact that there's a lot of people that think like me in the Go community where it's like, hey, I just want to use the best tool for the best job. And so I'm willing to, I'm not just going to be a Java EE developer, and that's the only thing that I'm ever going to do in my career. I'm going to be able to use the right tool. I think that's a more common thing for people working in Go than in certain other languages. Part of that also goes back to being a language that doesn't have vendor lock-in through being, my brain is completely farting, because it's open source. Another thing that's commonly mentioned, Go routines and channels. Again, I hit on this. Go routines and channels are relatively easy to understand comparatively to a lot of other systems for concurrency, and particularly languages that don't natively support concurrency, and you start getting into other ways of doing it that are not native to the system. Interfaces in Go, I mean, a few people touched on this. It's interesting. There are a few aspects of Go that it's like, okay, you can pretty immediately understand how to start using them. To figure out how they're powerful, usually it takes a little bit of time to wrap your mind around. But once you get going with them, it's like you begin to love them really quickly. I think interfaces is one example of that, where it's like, hey, a lot of people can immediately start implementing interfaces when they get into Go, but it's later down the line when they realize exactly how to do that really effectively and start to love it. Go's not inherently object oriented. So one of the reasons why I bring this up is just it's so common. It's so common to hear this from people coming in from other languages. They dealt with a code base somewhere, some other enterprise company, big company, working in Java, particularly Java EE or Python or whatever, C++, where I think we're all very well of the pitfalls of having this big inheritance system. And everybody talks about, hey, well, you're just writing bad object-oriented code if that's where you go with it. But the fact of the matter is, you work on a big code base, you're going to have people who abuse it, no matter how good your system is. If you've got 100, 200, 300, 1,000 engineers working on a system, somebody's gonna abuse it and figure out how to get it through the code review process. It will happen. And so then definitely having worked in Python and a few others, having to run up and down the inheritance system in order to figure out what kind of cascading problems you're causing by making changes becomes a huge hurdle. It's a pain in the butt. And a lot of people talk about that fact really openly when they move to using Go. Like, oh, I'm so glad I don't have to track down somebody else's really bad code that they wrote that I had no idea I was going to affect when I made a change to some parent somewhere. Object-oriented is inherently a little bit more complex because you are providing layers of further and further abstraction. It's that further and further abstraction that starts to complicate making choices. For me, this was really hammered home, again, when I started using Django and larger platforms where I felt like decisions were being made for me. The biggest problem wasn't that there was only one way to do it with that platform. The biggest problem for me was that I had no idea how performant that thing was. And I had to test to figure it out, right? Versus other things, because I don't know what else is added to that every time I do it. And so that leads to this, a lot of people are probably familiar with, I just wanted a banana, right? The creator of Erlang has this famous statement around, I wanted a banana and I wound up with a gorilla and an entire jungle. And that as his comparison for object-oriented programming. And I think that's very true. You get a lot of extra context that you really have no desire for or need for in a lot of cases when you get into these large OOP languages. Goes open source. If you've worked with people who, like, some people really love going and working in .NET for their whole careers. There's nothing wrong with that. But there's definitely vendor lock-in that happens in a non-open source language. And so the problem that you've got is that you're locked into contracts that increase in size. You're spending more over time, and you get further and further away from the ideal of being able to use the right tool for the right job. Because the fact of the matter is, if you're paying for a tool, you're going to use it, right? And your company is going to be incentivized to continue to use that tool because you're paying for it, and it's very difficult to do anything else. So I've talked to a number of people who really appreciate the fact that they feel like, hey, Go and similar languages, I feel like I can write in whatever I want, and Go is the thing that I choose to use, and that's a real positive. Ease of maintenance is a consistent theme, and it comes up through a number of different ways that engineers talk about ease of maintenance. Part of it has to do with readability. Like, if something's more readable, it's going to be easier to maintain. There's no question. It's also, as I previously mentioned, it's syntactically more simple, and it's fairly easy to write it pretty concisely. And by concisely, I'm not only talking about the size, but also about, in the most straightforward way. It's easier, in my opinion, and a lot of other people's opinions, to write Go that just makes sense and is relatively concise. And then, referring back to the previous slide, a lot of devs feel like, hey, I'm coming from a large OOP language, and I had to have a file for every single class that I've got, and I've got to format things in a specific way. And even though it might have made a lot of sense in the beginning when you've got a smaller code base, over time it gets so big and so bloated that I have to go searching for all kinds of stuff in order to figure out even where I'm going to be making changes to. And so they appreciate the fact that they can get back to more simple ways of doing things. And then this is also a common refrain that I hear when I talk to engineers using Go, is that they feel more confident jumping into a code base in Go that they don't know than they felt when they were working in a different language. Part of that has, I'll admit, and even at Route, we have some people who write Go very non-idiomatically. They came from a different environment. Particularly, we have one engineer who hasn't been in the company for a little while, but he came from a background of writing a lot of Java. And when he came in, he wrote Go like it was Java. And to be honest, he was a very senior engineer, one of my favorite engineers on earth, actually. He's super fast, very talented, but he wrote Go like it was Java, and nobody wanted to call him on it because he was just cranking out systems that nobody else was currently working on, and we just needed stuff to work. And so it was like, well, we can have the conversation about being idiomatic, but maybe now is not the right time, right? And so we added elements into our code base that definitely looked like Java. But what I will tell you is that, in my opinion, even his code that was written like Java in Go was far more understandable to people than systems that I had seen other places where people didn't really know what they were doing idiomatically and were writing non-idiomatic, for instance, Python. If you write non-idiomatic Python, you can get into some places where people really have no clue what you're doing. That's harder to do, in my opinion, in Go, and a lot of people that I've talked to feel very similarly. That's a major and powerful benefit of operating in Go if you feel like you're more empowered to jump into a code base that you don't know, in my opinion. So what's the TLDR? It's fast, it's light, it's easy to learn, has great concurrency. So, just high level, those are the themes that I hear consistently over and over and over again, talking to engineers about why they like using Go. Final thoughts here. So future-wise, things are just looking so great for Go. Fact of the matter is, we have a lot more companies that are using it. We have a lot more engineers who are getting acquainted with it and beginning to advocate for it, right? And we're, of course, getting more features. When I first started working in Go 6 years ago, it was a very common thing to hear, hey, I would love to have a library for XYZ. There's just not a lot out there. It's a totally different ballgame from 6 years ago. There's all kinds of stuff that you can go look at, and especially with modules now, like things are just, it's headed in a direction where you no longer have to hear the refrain over and over and over and over again. Hey, like, I would love to be able to just have something that does this for me. I don't trust that Go has a big enough set of libraries to do that for me. And then according to GitHub, I just pulled this a couple nights ago, actually. Based on the volume of pull requests into GitHub, currently, Go is the third most popular language in GitHub right now. Now, of course, there's the standard caveats. These are publicly accessible repos, right? But here's the thing, in my opinion, about publicly accessible repos. This is a bit of a side note. The most genius thing Adobe ever did, in my opinion, was they gave their software away practically for free to students. Because when those students went out into the world to every employer, they were advocating to go use the systems that they knew how to use, which was Adobe, because they'd been using it for free. Well, guess what? For the company, it's not free. It's very expensive, right? But they can afford it, not like those students could, right? I think the same thing is very true about what happens within software engineering, where you see people operating their personal projects and where you see people having excitement to go work in, that's going to follow. And eventually the companies will follow with it, right? We're going to build in things that people are excited to go advocate for. and for us to start building in. So in my opinion, to say that like the out of all of the publicly accessible repositories that Go is the third most popular, that's really exciting. And that's it. I hope I kept more of the audience this time. I appreciate you listening to me ramble for the last